Very good morning. So, today's class I will continue from the previous session. In the previous session, I was started with the color image processing. In the color image processing, some of the basic concept of color image I was discussed. Now, the today's sessions with the continuation from the last class, characteristics of colors. So we have used saturation and intensity. Intensity is nothing but brightness. HUIU is to be pronounced in the different ways, depends on the persons. Dominant wavelength in mixture of light waves. Dominant color perceived by observer. Saturation, the relative purity or amount of white light mixed with hues. Brightness, the chromatic notation of intensities. Pure spectrum colors are fully saturated. Colors such as pink is a combination of red and white. Lavender is a combination of violet and white. Usually they are very less saturated. In the case of chromaticity, hue and saturation get together, taken together. To proceed with some other concepts, here we are going to calculate some of the models or try simultaneous values. X equal to x divided by x plus y plus z. Similarly, the capital X, the amount of red required for colors. Y is nothing but green. Z is nothing but a blue. This color is defined as the previous slide. It's like this. And CIE chromaticity diagram. It varies colors, with gas are around in the different wavelength, ultraviolet to the infrared. These are the pure colors. In between that, these are the few colors. In the last class, I explained that white light passed through the prism, the Vibgeier light be considered. Other points in diagram represent mixture of colors. All points and boundaries are fully saturated. As point leaves boundaries and approaches point of equal energy, it becomes less saturated. Saturation at point of equal energy is 0. Straight line joining any two colors on the chromaticity diagram represent colors which can be formed by mixing of two colors. So colors mixed using like red and green. So red and white. See here the chromaticity diagram. So very clearly it indicates that the colors usually we observe in that slide You have mainly three colors: red, blue, and green is the dominated colors. And pink is a combination of red and green, deep blue. So like this is what the representation, basic chromaticity diagrams. And now we look into the color models. Color is specification of coordinate system and a subspace within that system where each color is represented by a single point. So here we have RGB models. First one is we call as RGB color model. So these three corners, black is at origin, white is corner farthest from the origin, line joining 2 points from grayscale. Different colors are a points on or inside the cube. Cube is a unit cube. The value of RGB in the range we considered only 0 and 1. This is what RGB color model. Schematic of the RGB color cube. Points along the main diagonal of gray values from the black at the origin, at white at this point. Now we look into that RGB color model. We are represented green, blue, and red. The combination of blue and red will become magenta. Combination of green and blue will become cyan. Combination of red and green will become yellow. And the all coordinate will be joined at single point, that will be called as a black. And see, look into that white colors. White. So black and white, in between the black and white will be gray levels, 0 to 255 gray values here. So it indicates that all types of 00B means RGB. R is 0, green is 0, blue is 1. R is 1, G0, B0. R0, green is 1, blue is 0. So that is what the representations, how we are going to use 001, 100, 010 in the RGB model. So here in the pixel depth, the number of bits used to represent each pixels in RGB space is called a pixel depth. The depth is equal to 24 bits. Each image plane is to be 16 bits. Such type of image is called the full color image. For example, we are going to consider total number of colors in 24-bit RGB, 2 power 8 bits into 3 colors. So all system safe colors, subset of colors that can be produced by any system. 256 is the safe color for any system. See here RGB 24-bit color model. What in the previous diagram mentioned, the same thing. These indicate the different blocks representation. And another two models, CMY and CMYK color models. C for cyan, M for magenta, Y for yellow colors models. So many color printers and copiers require these models. The CMY is in the previous RGB model, very clearly it mentioned that. So cyan will become 1 minus, right? magenta will become 1 minus green, yellow will become 1 minus blue. Therefore, pure cyan does not reflect red, pure magenta does not reflect green, pure yellow does not reflect blue color. In similarly, the same way RGB equal to 1 minus C, 1 minus M and 1 minus Y. Combining these CMY produces looking black. To produce pure black, fourth pure black color is added. So, model known as CMYK, where K is a black. The printing technique using these four colors is known as a four color printing. That is what we call as CMY and CMYK color models. The other model, very important model, that is what we call as HSI model, hue, saturation and intensity model. RGB and CMY describes color by giving its composite colors, but this is not practical method for human interpretations. When humans view a color object, they describe by its hue, saturation and brightness. So, obtaining these HSI from RGB, can take the intensity, take the RGB cube and stand it on the black 00 vertex with 111, white directly above it. The intensity is along line joining these vertices. To find the intensity component of any color space is color path A plane and perpendicular to intensity axis containing the color point, and the saturation of color increase as we move away from intensity axis. Saturation point at intensity axis is 0 by the fact that all points are green. The U form plane takes 3 points, black, white and color. All points in a plane, segment and points in the boundaries of cube of the same U. By rotating the plane on vertical axis, different U's are obtained. So, like that what I explained, that three models, one is RGB model, CMY model and HSI model. These three models are very important. So then we look into that, how to convert from one model to the another models. That is what we look into the next class. In the next class, we explain in details about to that. Thank you. Thank you very much.